Hi everyone, my name is Clementina.
And I'm Leah, and we're explainers at the New York Hall of Science.
Have you ever visited our minimal surfaces display in NYSCI's Mathematica exhibit? NYSCI might be closed right now, but we're going to bring this exhibit to you with an awesome activity that you can do from home. Today, we're going to explain what minimal surfaces are, but also get you to make some of your own. We'll conduct an experiment to explore this topic, so be sure to have a grown-up with you. So now, I'm going to go get the materials, and I'll let Leah fill you in with some background information.
So first, let's define what a minimal surface is. A minimal surface is a surface that locally minimizes its area and is usually used when trying to figure out the fastest way between 2 points. So when it comes to the science of minimal surfaces, one of the main objects of focus is a bubble. Bubbles create minimal surfaces because of the atmospheric pressure that's being applied in all directions outwards. This causes it to form a sphere. In our research about minimal surfaces, we came across a woman in STEM who has had a major impact on how bubbles are connected to the mathematical world.
Dr. Karen Ullenbeck is a bubble math researcher, and yes, that is a thing. She's also an Abel Prize winner who sees a mathematical universe in bubbles. Her studies involve minimal surfaces and bubbling to explore 3 dimensions and beyond, which have a direct influence on mathematical physics and analytical geometry.
So now, let's get to our experiment. So basically, we'll be blowing bubbles to explore minimal surfaces.
In our NYSCI exhibit, Minimal Surfaces, visitors can interact with each of the different shaped frames. Once each frame is dipped in the bubble solution, it can be seen that these shapes connect between all points on the frame while using the least amount of material possible. The bubble doesn't take the shape of the entire frame, but rather creates a smaller bubble in the middle. And this is because of minimal surfaces.
Now let's check with Clementina to see if she gathered all the materials for her experiment.
Okay, I'm back. Now I have all the materials. Now it's time for our experiment. We will need a bubble solution. If you want to learn how to make your own bubble solution, make sure to check out our NYSCI Bubble DIY. The link is in the description, or you can use any bubble solution you may have.
When I was younger, I had my own little electronic bubble blower that played music, and I thought it was so cool the way a little machine can make bubbles come out. From doing some experimenting, I have found a way to make a bubble wand. Now, let's create it together. Make sure to have all your materials with you, pipe cleaners and popsicle sticks. First, grab a pipe cleaner and with the end of the pipe cleaner, create a shape. Repeat this process with 1 or 2 more pipe cleaners and remember to include a circle. Once you are done creating the shapes, grab a popsicle stick for each shape you made and use the opposite end of the pipe cleaner and wrap it around the tip of the popsicle stick. Think about it as making a loop around the popsicle stick. Once you complete this for all the shapes, you have now created your own bubble wands.
So here I have all of my bubble wands and my bubble solution. So now I'm going to grab one of my bubble wands, dip it into the bubble solution, and blow on it. Let's see what happens. What shape are our bubbles? Is it the shape we made with our pipe cleaners? No, it's a sphere. Why? Well, this is because of minimal surfaces and air pressure. Bubbles create minimal surfaces because of the equal atmospheric pressure being applied on all directions outwards. This creates a sphere, regardless of the bubble wand shape. So remember, no matter what the shape of your bubble wand is, the bubbles will always be a sphere.
So we covered quite a few concepts today. Let's remember what they were. So we talked about minimal surfaces, which is a surface that locally minimizes its area, and we usually use it when trying to figure out the fastest way between 2 points.
Through our experiment, we also talked about the shape of minimal surfaces through bubbles, which is usually a sphere because of the equal amount of air pressure on all sides.
And this concludes our video on minimal surfaces. If you would like to know more, come visit our exhibit, Minimal Surfaces, when NYSCI reopens.
And if you like this video, please make sure to give it a thumbs up and subscribe.
Thanks for watching!